If I told you that the largest galactic structure in the universe contradicts the theories of the formation of the universe, what would you say? Would you say, "Move faster, I saw this episode 5 years ago"? So, let's start with the galactic filament, a structure that defies our understanding of size. Its name, the Hercules Corona Borealis Great Wall galactic filament, or, more plainly, a supercluster of gravitationally bound galaxies. It is the largest known structure in the observable universe, measuring approximately 10 billion light-years in length. For comparison, the Milky Way, our galaxy, spans only 200,000 light-years, while the distance from the Milky Way to our nearest neighbor, the Andromeda Galaxy, is a mere 2.5 million light-years. Another massive structure, the huge large quasar group HUGE-LQG, pales in comparison, measuring only 4 billion light-years, less than half the size of the Hercules Corona Borealis Great Wall. This structure was first observed through gamma-ray burst mapping, revealing an unusually high concentration of gamma rays compared to the average distribution. The Great Wall of the Sky was discovered in November 2013 by a team of American and Hungarian astronomers, including Ivan Horvath, John Hakala, and Jolt Bagley. They analyzed datasets from NASA's Swift gamma-ray burst mission, combined with ground-based observations. Until this discovery, the HUGE-LQG was considered the largest and most massive structure in the observable universe. So, what are gamma-ray bursts? These are the most powerful explosions in the universe, originating from massive stars. To put it into perspective, a single gamma-ray burst releases more energy in a fraction of a second than our Sun will emit in its entire 10 billion year lifespan. These bursts are rare. In a typical galaxy, one occurs only every few million years. The immense mass of the stars producing these bursts implies that the region around the Great Wall is incredibly dense. The Great Wall spans the second, third, and fourth galactic quadrants, observable from the northern hemisphere. It is centered near the border of the constellations Draco and Hercules. Galactic quadrants are essentially a coordinate system that divides the Milky Way into 4 circular sectors, using the Sun as the system's center. All astronomical observations thus far have been relative to Earth, so this method is practical for mapping the galaxy. Now, you might be wondering, how did scientists conclude this is a structure and not just a cluster of stars? Initially, the researchers didn't even name it. The term Hercules Corona Borealis Great Wall was coined by a Filipino teenager, Alejandro Valdez, after reading a Discovery News report. The name caught on and was later used by the original Discovery team, despite being somewhat misleading. The structure is round, not elongated, as the term wall might suggest, and it spans a far larger region than the constellations of Hercules and Corona Borealis imply. The team determined the Great Wall's size by analyzing gamma-ray burst data. Of 31 recorded bursts, 14 were concentrated within a 45-degree section of the sky, translating to a structure approximately 10 billion light-years across. This equates to 10.7% of the observable universe's diameter. The Great Wall crosses over 20 constellations and spans 120 degrees of the sky. Statistical analysis played a crucial role in confirming this structure. Researchers used a bootstrapping method and the Kolmogorov-Smirnov test to compare gamma-ray burst distributions across 9 regions of the sky. Their simulations showed significant clustering in the region associated with the Great Wall, far exceeding what would be expected from random distributions. Despite this evidence, the Great Wall's existence remains controversial. A 2016 study argued that the gamma-ray burst distribution could be explained by random chance, though later studies in 2020 found even stronger evidence supporting the structure's existence. However, resolving this debate will require more advanced observational data, potentially from future satellite missions. The discovery of the Hercules Corona Borealis Great Wall challenges fundamental cosmological principles, including Einstein's cosmological principle, which posits that the universe is homogeneous and isotropic on large scales. According to this principle, structures larger than 1.2 billion light-years shouldn't exist. Yet, the Great Wall's size 8 times that limit defies this notion. Moreover, the structure's formation seems impossible within the universe's 13.8 billion year timeline, raising questions about our understanding of the Big Bang and cosmic evolution. Even the researchers who discovered the Great Wall admit they don't know how such a colossal structure could have formed so quickly. For now, it remains a mystery, a potential challenge to our understanding of the universe's origins and evolution. As our observational techniques advance, we may uncover new insights into this extraordinary cosmic phenomenon, reshaping our grasp of the universe's fundamental laws.